Now we know a little bit about how generic methods work, but let me review and reinforce some ideas here. The generic type parameter toutput, that's available all throughout the method definition. That's why I can use toutput as a return type. I can use it in the typeof operator. I can also use it in a cast operator. I can even declare local variables as type toutput, but that would force me to move the cast operator up here to make sure I have a compatible assignment. Even though convert always returns an object reference, the underlying object should be of the type we asked to convert to. So toutput should always succeed here. Otherwise, the convert to method itself will throw an exception. And inside of this method, as enumerable of toutput, I actually have access to two generic type parameters. I have access to toutput because it is a generic type parameter to this method. I also have access to t because it is a generic type parameter for the class that this method is a part of. So I have access to both, but a generic method doesn't need to be part of a generic class or generic interface. It can be an instance method or a static method on a non-generic type. And that's certainly true for extension methods. I go into all the details of extension methods in my LINQ course, so please watch that if you have never seen the syntax or heard the background on why extension methods exist. But let's say I've changed my mind and I do not want as enumerable of toutput to be part of my buffer definition. It's not used by every piece of code that uses a buffer. It's only used in some exceptional cases. So in that case, I might remove it from the class. I'll do a cut operation there. I'll also remove it from my interface definition. And I'm going to define it as an extension method instead. As an extension method, it could live in a different namespace that is only in effect for those exceptional circumstances. And that way it doesn't clutter up my buffer API in the nominal case. So let me add a new class to this project. Hit Shift-Control-A. I want a class called Buffer Extensions. And as a host for extension methods, this will need to be a public static class. And now I can paste my method inside of here. It's going to need a few things fixed up though before it can work properly as an extension method. First of all, as an extension method for buffer, what I'm going to need is a parameter that has a this keyword in front of it. That's what extension methods are all about. Again, that's in the LINQ course. And what's the type that I want to extend? Well, basically, I want this to be available for all buffer of t. Buffer of int, buffer of double, buffer of string, doesn't matter. I just want it to be available for all buffers. The complication here is that t is a type parameter that I did have access to when I was in the buffer class, but not inside of this method. This method is now part of a static class. The static class doesn't take any generic type parameters. I have no generic type parameter t that represents the type of the buffer, the type of the values that I need to convert. Where am I going to get that from? Well, I could add an additional type parameter to this method. So just like classes and interfaces can take one or more generic type parameters, a method can also take one or more generic type parameters. You just separate them by a comma. And now as an extension method, this is also going to have to be static. So now I have a public static method that returns IEnumerable of toutput. It is as enumerable of t and toutput. It's an extension method for iBuffer of t. And the job it needs to perform right now can be the same. We need to use a type descriptor from the system.componentModel namespace. I'll bring in that namespace. That will give me a converter. I don't have access to the underlying queue anymore, but since the buffer does implement IEnumerable, I can write a for each statement to go through it. So for each item, we'll use the converter to convert that item to type of toutput and return the result. Let me go over to the program, and I'll see that there is just one hitch here. As enumerable of is now a method that requires two type parameters. And because of that syntax, the C# compiler won't be happy until I essentially say that t is of type double, toutput is of type int, but now I should have an extension method that is available for any type of iBuffer of t that will do some conversions for me. So if I give it a 4.1 and a 5.9 and then quit, it's still behaving the same. But the point of this exercise was really just to show you that I can use generic type parameters on a method that is not part of a generic type. Furthermore, I can use multiple generic type parameters. And just so you know, generic type parameters are part of a method signature. The method signature is what the C# compiler uses to determine distinct methods. It uses the name of the method, the types, and the number of method parameters, as well as the number of generic type parameters to that method. It doesn't use the return type, but you probably knew that already. And that just means if for some reason I needed an as enumerable of that took 3 generic type parameters, then that would be seen as a different method definition by the C# compiler. But if I just had 2 type parameters, even if they had different names, well, now the C# compiler would be unhappy and will basically be telling me that I already have a member called as enumerable of with the same parameter types, referring to the actual method parameters, because it doesn't see the difference in the generic type parameters. The names really don't matter there. It goes by the number. But I could certainly have as enumerable of with 3 generic type parameters or 1 generic type parameter. That would make the C# compiler happy. It just so happens I cannot do that in this situation because I need exactly 2 generic type parameters. And now if I do a build, we should be back to working. What if I wanted to write another extension method that would make it very easy to loop through the buffer and dump out the contents to the console? Essentially console.writeLine each item, but not after converting it, just writing it out. Well, let's try to write that one in buffer extensions once. This will also be a public static method, but this one can return void. All of its output goes to the console. It's still going to be an extension method for iBuffer of t, and we'll call that parameter buffer. But where does the t come from? Once again, we'll need a generic type parameter here that the C# compiler can use to parameterize the rest of the class, and at runtime it'll be an iBuffer of int or double or string. And then I can just have a for each loop for each item in the buffer. Let's console.writeLine that item. And with that extension method in place, this extension method with 1 generic type parameter, let's come back to the program and say buffer.dump. Now notice in this situation, I don't need to pass the generic type parameter and the C# compiler is still happy. I could say dump of double, but in reality, the C# compiler has already figured that out. The C# compiler tries to be very aggressive so that when you invoke a method that requires a generic type parameter, the C# compiler will try to infer what that parameter is when you invoke the method. And if I pass in the wrong generic type parameter, the C# compiler will be able to figure that out. So how does it figure this out? Well, it knows that dump as an extension method for iBuffer of t, well, if I'm invoking the method on an iBuffer of double, then double must be the type to use as the generic argument here. It doesn't make sense to dump int on an iBuffer of double. I would have to go through some conversion operation like I do with as enumerable of. So therefore, C# compiler can be pretty smart, and I can invoke dump without using that noisy generic type parameter, which is nice. With as enumerable of, it's a little different story. It knows I'm invoking this extension method on a buffer of double. It would be able to figure out this generic type parameter, but the int sort of comes out of nowhere. There's no additional parameters that are passed into that method that the C# compiler would be able to use to infer what that type is.